Hello friends, I am here with a new Arduino training video. This is the fourth video of the series. If you have not watched it, I recommend you to watch the previous videos. I hope you will forgive me for not having time to shoot videos for a long time. Let's quickly move on to training. Have a good time. Let's quickly remember the codes we wrote in the last video and the circuit we built. If you haven't forgotten, we assigned pin 2 of the digital pins as the output pin. And we told Arduino to energize and de-energize this pin at certain intervals. We said that Arduino reads the void setup header only once, understands the pins we assign to the definitions we write, and immediately enters the void loop. And it makes a very fast and continuous loop within the void loop. We can also set the timing we want in this loop with the delay command. We have said that Arduino works with the logic of ones and zeros like almost all electronic circuits. 1 means that there is voltage in Arduino, and 0 means that there is no voltage. So we can provide energy by writing high to pin 2 or by writing 1. Likewise, we can de-energize it by writing 0 or low. Now we will make an application similar to this application. This time we will build a sequential LED circuit using 6 of the digital pins. For convenience in the codes we will write 1 instead of high when we output to the pin and 0 to de-energize. First, let's see how this code works. This time I will use a blue LED. I connected the GND with a black wire and connected the output voltage from pin 2 to the positive leg of the LED with a 10 kilo ohm resistor. The reason I use resistors here is to ensure that the LED works properly. If you do not know which resistor should be used in which circuit, you should learn about basic electronics. I recommend you to learn Ohm's law about resistors. Yes, the LED flashes on and off with a 1-second interval. I want you to pay attention to one thing here. Now I remove the cable that I connected to pin 2 and connect it to pin 0 on the Arduino. As you can see, even though we haven't assigned pin 0 as an output pin, voltage is coming out of it. It's the same as pin 1. I try other digital pins except pin 2, but no voltage comes from the others. If you remember, we said that pin 0 is RX and 1 is TX, i.e. communication pins. If you do not tell Arduino what you want to use these pins for in the code, these pins will remain open for communication. For example, if you want to use pin 0 and 1 as output pins, it will work that way. But every time you restart Arduino, the RX and TX pins will give direct output voltage and then work as specified in the code. You should pay attention to this in your projects. Let's continue. In this circuit, I will use 6 blue LEDs. So I inform the Arduino that the pins that will supply voltage to the LEDs will be the output pins. I will use pins 2, 3, 4, 5, 6, and 7. With the same logic, we will repeat the codes in the void loop for all the pins we have determined and assign the time interval we have determined. Here you can copy and paste in general, but if you want your hand to get used to writing code, it is better to write one by one. In order to turn on and off the pins we have identified one by one, we ask the Arduino to make each of them 1 and 0 at 1-second intervals. If you pay attention, for example, after making pin 2 0, that is, after turning off the LED, I pull pin 3 to 1, that is, to the on position without giving a time interval, and the other pins in the same way. What I mean by doing this is that I want the LEDs to follow each other fluently. Yes, we can build our circuit after writing the necessary codes for pins 2 to 7. I prepared 6 blue LEDs, 6 10 kilo ohm resistors, and jumper cables for the circuit. I connect the short, negative leg of the LEDs directly to the GND line. I pass the long legs through the resistor and connect them to the digital pins from 2 to 7 that we specified in the codes. The legs of resistors do not have a plus or minus side, and there are many sites and mobile applications available to read the resistor values from their colors. You can find them by typing resistance calculator in the search engine. I make cable connections after the resistors. Since the code we just installed is still working, there is voltage output from pin number 2. I disconnect the data cable for convenience. Everything is ready, and I plug the data cable back in. Yes, let's install the new code. Good. Our LEDs light up at 1-second intervals. This seems a bit slow. Let's make the time interval 500 milliliters seconds. Let's upload it again. I will make 300 milliliters seconds to make it work a little faster. Notice that the LEDs only go from right to left and back again. I want them to turn on and off from right to left and back again from left to right. For this, we will copy the code sequence inside the void loop and just reverse the pin numbers. So from pin 7 to pin 2. I copy these codes and put them below. I am deleting this statement. After pin 7, I start at pin 6. Let's see how it works this way. I think the order is not correct. Let's start again from number 7. Now it lights from right to left and left to right, but there is a pause in the LEDs connected to pins 2 and 7. We can fix this with time intervals. Delete the delay command here and try this. The problem with pin 7 is solved, but pin 2 is still there. Let's fix that too. I think for this we should not delete the delay command at the end. Yes, it's exactly what I wanted. Now I'm speeding it up a little bit more. That's it for this video, friends. I hope it was understandable and useful for you. Your opinions are important to me, so you can let me know in the comments. I left the codes directly in the description. You can copy and use them from there. Thank you for watching. Take care of yourself.